Hello everyone, welcome back to my channel. So today we'll be looking at the derivative of a quotient. Now the quotient rule or the quotient formula is the formula that is used to find the derivative of a quotient or a fraction of any two functions. Now let's say we have a function or an equation y equal to u over v, right? Now this is our numerator and then this is our denominator. Now both u and v are functions of x. And so in this video I'll be showing you guys the derivative of a quotient function. So we've stated earlier that u is a function of x and v is also a function of x. So using first principle approach, we have that y will be equal to y plus delta y, and then u will be u plus delta u, v will be v plus delta v. And so if we subtract y from both sides of the equation, we have that y plus delta y minus y equal to u plus delta u over v plus delta v minus y. Now y is u over v, right? So on our left hand side, y will subtract y and then we have just delta y. And then on our right hand side, we'll find the LCM of this equation. So our LCM will be v plus delta v multiplied by v. And so if we solve this further, we have that u plus delta u multiply v minus u multiply v plus delta v. So let's open this bracket. So we have that u multiply v is uv, and then delta u multiply v is v delta u minus u multiply v is uv, and then u multiply delta v is u delta v, and then we have v plus delta v all over v. Now u will subtract u, and so we have delta y equal to v delta u plus u delta v over v plus delta v multiplied by v. Now if we divide both sides of our equation by delta x, we'll have that delta y over delta x is equal to v delta u plus u delta v. This will be over delta x over v plus delta v. Now if we solve this further by taking the limit as delta x approaches 0, before we take the limit as delta x approaches 0, we need to state some things. As delta x approaches 0, delta u also approaches 0, and then delta v also approaches 0. So by taking the limit of this function, we have that limit as delta x approaches 0 of delta y over delta x is equal to limit as delta x approaches 0 of v delta u over delta x plus u delta v over delta x over v plus delta v. And so we can simplify this further This becomes limit as delta x approaches 0 of delta v rather delta u over delta x minus limit as delta x approaches 0 of u delta v over delta x. This would be over v plus delta v. Now we can also simplify this further to be this. This becomes v limit as delta x approaches 0 of delta u over delta x minus u limit as delta x approaches 0 of delta v over delta x. Now this is over v multiplied by v plus delta v. And so solving this further, we have that we know that the limit as delta x approaches 0 of delta y over delta x is equal to dy, the differential of y with respect to x. So we can write this as dy over dx equal to, now this is v, this becomes v as delta x approaches 0 becomes du over dx minus u limit of this, which is dv over dx. This becomes over. Now v, we stated earlier that as delta x approaches 0, delta u also approaches 0, and then delta v approaches 0. So if we put delta v to be 0 in this equation, we have v squared as our denominator. So this becomes our quotient rule formula.